Welcome back to Operating Systems Crashcast. I'm Victor, and today we're diving into Section 3.3, Operations on Processes. Sheila, are you ready to explore the life cycle of processes?
Absolutely, Victor. This is a crucial topic for understanding how operating systems manage processes. Let's start with the basics: process creation and termination.
Great idea. In modern operating systems, processes are created through two main mechanisms: the fork system call and the exec system call. The fork call creates a new process by duplicating an existing process, while exec replaces the process's memory space with a new program.
That's right, Victor. It's like a cell division in biology where fork creates an identical copy of the parent process, but exec is more like metamorphosis, completely transforming the process into a new program. Can you elaborate on how these two calls work together?
Certainly. In Unix-like systems, it's common to use fork followed by exec. The fork creates a new process that's a copy of the parent, and then exec is called to replace the child process's memory space with a new program. This two-step process allows for flexibility in setting up the new process before it starts executing the new program.
That's a great explanation. It's worth noting that Windows systems use a different approach with the create process function, which combines the functionality of fork and exec into a single call. Now, let's talk about process termination. How do processes end their life cycle?
Processes can terminate in several ways. The most common is when a process finishes its execution naturally. It can also terminate if it encounters an error or receives a signal from the operating system or another process to end. In Unix-like systems, processes use the exit system call to terminate voluntarily.
Exactly. And it's crucial for processes to clean up after themselves when terminating. This includes releasing any resources they've allocated, such as memory or file handles. Victor, can you explain what happens if a process doesn't terminate properly?
That's where we get into some interesting territory, Sheila. If a process doesn't terminate properly, it can lead to what we call zombie processes. A zombie process is one that has completed execution but still has an entry in the process table.
Ah, zombies. Not the horror movie kind, but still a bit scary for system administrators. Can you explain why zombie processes occur and what problems they can cause?
Sure thing. Zombie processes occur when a child process terminates, but its parent process hasn't yet called wait to collect the child's exit status. The process table entry is kept so that the parent can retrieve this information later. While zombies don't use system resources, they do take up space in the process table, which is finite. If too many zombies accumulate, it can prevent new processes from being created.
That's a great point, Victor. It highlights the importance of proper process management by parent processes. Speaking of which, what happens if a parent process terminates before its children?
That's when we encounter orphan processes, Sheila. When a parent process terminates before its children, the operating system typically reassigns the orphaned processes to a special process, often called init, in Unix-like systems. The init process is the first process started during system boot and acts as a parent for all orphaned processes, ensuring that every process always has a parent and maintaining the process hierarchy.
Excellent explanation. This parent-child relationship in processes is quite similar to a company's organizational structure, isn't it? Just like how a departing manager's tasks are reassigned to ensure continuity.
That's a great analogy, Sheila. It really helps visualize the process hierarchy. Now let's talk about the historical context of process management. The concepts of fork and exec were introduced in early Unix systems in the 1970s. They've stood the test of time and are still fundamental to modern operating systems. However, their implementation has evolved to become more efficient over the years.
Indeed, Victor. And while these concepts are still relevant today, modern operating systems have introduced additional mechanisms for process and thread management to improve performance and utilize multi-core processors more effectively.
Absolutely right, Sheila. As we wrap up, let's recap the key points we've covered about operations on processes.
Great idea, Victor. We discussed 1. Process creation using fork and exec. System calls 2. Process termination and the importance of proper cleanup 3. The difference between zombie and orphan processes 4. The significance of the parent-child process relationship 5. The historical context and evolution of process management.
Excellent summary, Sheila. Understanding these concepts is crucial for anyone working with operating systems or developing software that interacts closely with system processes. It's also a common topic in technical interviews for operating systems roles.
Absolutely, Victor. Listeners should pay special attention to the differences between fork and exec, the implications of zombie processes, and the importance of proper process termination. These are all key areas that interviewers often focus on.
Great point, Sheila. Well, that brings us to the end of today's episode on operations on processes. Thanks for tuning in, everyone. In our next episode, we'll be diving into inter-process communication, so be sure to join us then.
Thanks, Victor, and thank you all for listening to Operating Systems Crashcast. Until next time, happy coding.